D. Madhavi. Today I am going to discuss about heaps. Heap is a data structure which permits to insert elements into a set, and we have two types of heaps. One is min heap and the other one is max heap. So in min heap you have the minimum element at the root. Say for example, this is an example of min heap. So here you can observe that the root node always the minimum element, and you can also insert some more elements. 55, always insert at the left child and then come to the right child. 65. So here 55 and 65 both are greater than its root, that is 45, and 45 is greater than its root 15. So it is satisfying the min heap property. Similarly, you can have some elements as say 35 you can have here and 75. So here also the root is 25 and it is the minimum element at the root of this subtree, at the root of this subtree. So this is the minimum tree, minimum heap, and it is almost a complete binary tree. It is almost a complete binary tree. And what is the restriction? The restriction is the minimum element should be at the root node. And coming to the max heap, its constraint is the root element should be always the maximum element in the list. Say for example 95, and its next insertion will be left child, any element like 85, and the next insertion will be at the right child, any element, say for example 45. So if you observe here 85 and 45 are less than its root, that is 95. You can also extend the tree inserting some more elements, that is say some 75, and here it may be some 25 or like that. Similarly, you can also extend the tree by inserting 35 and also 15. So if you observe for this subtree, 85 is the root and 85 is greater than both its children 75 and 25. Similarly, for this subtree, right subtree, you can observe that 45 is the root and it is greater than its children 35 and 15. And if you observe for the entire tree, 95 is the root node and it is the maximum element. So this is called as max heap. Since the heap is a complete binary tree, the root of the tree is in location 1. Always the root of the tree is in location 1. And the left child of an element stored at location I can be found in location 2 star I. So always you can find the left child at 2 star I. So what is I here? I is the location where the element is stored. And the right child of the element is stored at location I can be found at location 2 star I plus 1, because left child is at 2 star I, right child will be at 2 star I plus 1. And the parent of an element stored at location I will be found at I by 2 floor of location. So you can store a heap in an array in a systematic way. Say, if X is an array, you can first store, say in C the index starts at 0, so in X of 0 you can store 95, because that is the very first location. And in X of 1 you can store the first left child, that is 85, and then you can store the next right child 45. Okay, and then you can have the children of left child, that is for 85 the children are 75 and 25, first left child and then right child. Okay, and then you can also store the children of right child, that is 45. So 45 left child is 35 and right child is 15 at positions 5 and 6. So this children, left child and as well as right child. Okay, and 85's children are 75 and 25 together. So this is how you can store the elements of a heap into your traditional single dimensional array. So now we'll see the operations of heap. The operations are mainly deletion and merging. So first we'll see the insertion operation, insertion into a heap. So first I want to see the insertion operation in min heap. Say for example 5, 1 and 8. So now first I will insert 5 and then I will try to insert 1 as its left child and then try to insert 8 as a right child. So before doing that, because it is a min heap, so the minimum element should be at this root. So I cannot do this operation. Only thing is I have to first reheapify this heap in order to maintain the min heap property. So in order to maintain this, I am going to swap 1 to the root and 5 to the left child. Now it is time to insert 8. 1 is the minimum element and your min heap is constructed successfully. Now I want to construct. I'll take the same elements 5, 1 and 8. So now first you insert the first node as 5 and then you insert 1. Now it is satisfying the max heap property because 5 is greater than 1. Now what is the next step? Insert the next element 8. So 8 is greater than 5. So at this point, this is violating the max heap property. So I will perform a simple swap So 8 reaches the root and 5 reaches the right child position and 1 remains as it is. Now this is your max heap. Your max heap is constructed because the root element is the greatest among all the things. So in the next class, deletion.